Hi, Jonah. Thanks
Hi.
for being here at the DVX at Mannheim, and thanks for having us and joining our interview here at the Developer World Experience. We're talking about event-driven and cloud-native apps in .NET using Azure Functions on container apps, Azure Container Apps.
Yes.
That sounds really cool. So my first question is, what are the key advantages of combining all these technologies like Azure Functions, Azure Container Apps with event-driven architectures in .NET?
Yes, that's the great question. And first of all, it's great to be here. It's my first time speaking at a DWX conference. It's great to be here. But to answer your question is that I do see the power of synergy. I did mention in my talk the synergy of Azure using Azure Functions or developing Azure Functions and build it into Azure Container Apps. It's because these two technologies are powerful cloud-native technologies within Azure. So Azure Functions allows you to like event-driven functions, and Container Apps allows you to integrate it with Docker and KDA technologies. So in my perspective, the benefits of choosing to host your Azure Functions into a Container Apps is the feature that depends on your use case. For example, if you have a use case that requires microservices architecture or that requires SCADA for like scaling within the Kubernetes, for example, or if you have this like Docker integration, then I do believe that that's a good feature. Consideration to do. And another option is also if you're building AI solutions with Azure, of course, cloud native allows you to integrate from all compute services, including monitoring and other types of services. But with Azure Functions in Container Apps, you'll be able to utilize these two features that Azure Container Apps has, and that is the new feature that they released last year on Ignite, the serverless GPUs, which is very useful if you're running AI workloads, a lot of them, and the dynamic sessions and also the workload profiles if you want to have this dedicated compute and performance per environment or per workload in your container apps.
Great. How does the programming model for Azure Functions differ when running inside container apps compared to traditional function app hosting, especially when regarding scalability, networking, custom dependencies?
Okay, that's very interesting question in my perspective. I believe that, like for example, if you're just like using Azure Functions as it is, you are kind of like tied into the runtime of the Azure Functions, like just say that .NET and then JavaScript or PowerShell. But if you have this integration or putting your Azure Functions in a container apps, you have more flexibility in doing that because you have you can host it in a container, of course, and containers allows you to like build it as microservices that are not dependent. It's kind of like distributed computing, and then you can integrate it with other services within Azure or other open source services or AI integrations as well. So one of the features as well with Azure Container Apps with Azure Functions in it is the option of like workload profiles that allows you to create specific workload or kind of like profile for specific environments depending on the requirement for compute, compute storage, for example, and also the serverless GPUs, which is very good if you're like building high intensive compute kind of solutions such as AI or Azure OpenAI, and also dynamic sessions, which is also pretty good when it comes to like working with serverless integration with Azure Container Apps. So there's a lot of more. One of the things that I shared in my talk today was the questions of cold start, because that's
Okay.
also one of the
Yeah.
challenges of developers, like common questions, how do I deal with cold start? So of course,
Okay.
one of the answers for that is like you should have like consider doing the higher hosting plans, such as dedicated plans or profiles for Azure Functions. But you can also utilize the new .NET features, which is from .NET 8 to above, like .NET 8. There's this AOT kind of like native development that you kind of like run your profile as like self-hosted container in advance. So that's for .NET, but probably there's other solutions for that in other like programming languages.
Cool, cool. What patterns or best practices have you seen on your experience in your project for managing state retries and failures in cloud native and event-driven systems built with .NET and Azure services like Event Grid or Service Bus?
Okay, that's interesting, because I spoke about Azure Functions, but
Yeah.
also there's also like Event Grid and also Azure
Correct.
Service Bus. I think all of this like services that handle events, such as Azure Functions, Event Grids, and Service Bus, they are very special in a unique way, because Service Bus, for example, is for like enterprise messaging broker system. It has its like features like handling dead letters and retries. But when you're building, for example, with Azure Functions, like especially durable functions, there's two options. So let's just say if you have this complex workflow in your event-driven architecture, let's just say parallel tasks or to-dos that you need to do during an event. So you might want to consider durable functions to run stateful workflows in a function, like in a fan out, fan in fashion, using durable functions in that way, and then using the retry when something fails, and effective troubleshooting and error code handling when during try catch. Like coding part of it, and most of all, observability and monitoring plays a vital role when you're working with cloud native development, especially the Azure Functions or container apps, because if something goes wrong, you don't have any monitoring inside your applications that are microservices, then it's very hard to debug. Where is the problem? Is it on the user's service?
So the problem to localize it where it is, yeah?
Yes, yes. So I think monitoring, error handling, and not making your entire architecture too complex. Just scope it into like not that it doesn't get too big, too huge, you know, because if the more complex it is, the more harder it is to solve some problem and troubleshoot it.
Okay.
Yes.
What are the most common challenges developers face when building distributed event-driven .NET apps on Azure, and how do you typically solve them, or how do they typically solve them? Have you any recommendation for .NET developers how to handle these problems?
Yes, I do. That's very interesting. One of the things that I can recommend is like, don't make your events or Azure Functions too complex in a way that you need to find a solution first. I mean, the best possible type of Azure Functions that you need to use. Like one example was that using durable functions, when you have this function chaining of events, using the fan out, fan in pattern if you are like running multiple tasks at the same time. So for me, like if you need something that needs to be like in a workflow type, then durable function is good. But if you just like use a standard stateful thing, then you can just use the Azure Functions, the standard one. But one common challenges that I know I myself also as a developer is troubleshooting. Like where is the issue? Like for example, if you don't have the proper monitoring, it's hard to find out if the problem is in your C# code or your code, or it's the problem within the integration.
And what do you recommend as solution for that problem?
And for solution for that problem, I would like proper debugging like strategies, like error handling on the code, but not just in the code, like in .NET code, but also using monitoring or observability such as Azure Monitor, for example, and App Insights for that. And then I also see a challenge of like security, like protecting your API keys on your Azure Functions or container apps. So it's always good to use this security best practices for like Azure Functions or container apps, that the typical common developer like best practice to keep your secrets and credentials in a secure place. And that means that you're utilizing, for example, managed identities for like permissions and like Azure Key Vault for secret management and many other things that protect your APIs or your event-driven applications from the public that are giving security risks.
Great.
Yes.
Thank you very much, Jonah, for sharing your insight and your experience to our customers and our readers at the .NET Pro magazine and here at the Developer Week. And have a nice day. Thanks a lot.
Thank you for having me.
Thanks. Bye.